morning again. Dan, thank you very much for the warm welcome, and thank you all for being here. As Dan mentioned, the weather played some tricks on us yesterday, so for those of you that are here, I'm glad that you're here. I'm going to be talking about automation. As Dan mentioned, I've been doing automation for the last 20 years, and I've been talking to people about machine tool automation for pretty much that whole time. And what I really want to do is give everybody a little bit of history about why people automate, why people have automated in the past, why people continue to automate, what are some of the latest trends in terms of the new things in automation, and how it really technically relates to your business step by step. So I am going to have some questions at the end, so I'll get through this. I have about 30 slides. It'll probably be 35 minutes or so of me talking, and then please let's open it up and just have an open discussion at the end. Let us know any sort of questions or challenges that you might have. So we'll get started. Here's some of the key takeaways. I tend to walk and talk too, so bear with me. The first is automation right for you. Within the room here today, it looks like we have a lot of end users. We probably have a lot of the machine tool distributors from Mazak, as well as a lot of the Mazak actual employees. And so this message is relevant to everybody in the room. It's relevant to the end users. It's relevant to people that are trying to sell machine tools, as well as the OEMs themselves, trying to understand where does automation fit and what part of your business is it right for. The next, I want to go through some of the benefits. What are some of the advantages that you see when you actually begin to automate, and how does it affect your business? We'll talk about how to get started. I want to offer some reassuring words that you can actually do it. You can actually automate and be successful at it. And then we're going to talk about employees, and we're going to talk about workers and skilled workers, because when we start talking about automation, the idea of skilled workers and employees always comes up, just because inherently about what robots do and what role they play in the automation space. And then I'm going to wrap up the presentation with what are some of the latest trends. Okay, so let's get started. First and foremost, I want to talk about the market, because is the market right for automation? And this is an area where I'm not sure people understand where the correlation between the machine tool market and the robotics market is. So most of the people in the room probably know very well this chart, which is the machine tool market. And the machine tool market, since the recession, this is only since 2015, we have been on a tremendous growth path since the recession. However, in the last 12 months or so, the machine tool market has softened, and we've been on about a 12-month decline in the overall machine tool market from a capacity utilization standpoint and from an overall sales perspective. You can see there that about October of last year, from a 3-month moving average, we started to decline. What about automation? Let's relate that to automation and see how this market relates to the robot market. So this is machine tools. This is in dollars. But right now, in the North American machine tool market from AMT, the overall market is about 25,000 machine tools in a year. Just keep that in your mind. That's about what the market is, 25,000 machine tools. So this cut is robot data. And this is the same time frame from 2015. And you can see that it's been on a generally strong growth trend since that time. Now here's the challenge with these numbers. It takes a minute to kind of explain it. Machine tools, it's easy to talk about. You sell a machine, you report it. With robotics, when we report what robots do for a living, we don't have a specific category that says that this robot was put on a machine tool and sold that way. We categorize robots by what kind of robot it is and then what industry it's in. So this grouping is, this grouping is just material handling robots. These are robots that are used in a material handling application. That doesn't necessarily mean they're attached to a machine tool. Material handling robots can be in an automotive body shop moving car frames around because they're material handling. Material handling robots could be in a bakery handling boxes of food and things like that. And you can see that the numbers here, 4,000 or 5,000 robots every quarter, correlates to things much more than the machine tool business. But the market's going up. The other way that we look at robot data, the other way that we look at how to view a robot is what industry it goes into. So first there's application, and there's material handling and arc welding and spot welding and painting and other areas where a robot, what type of robot it is. And then the next is an industry. And this industry is where all the machine tool automation robots get lumped into, and this is in the metals industry. So this correlates a lot better with the machine tool industry, although it also includes some arc welding robots as well that are in metals. So this is any robot that's touching or within the metals market. So it's mostly machine tool tending robots, but there's also welding robots in here, and there's also deburring and other finishing robots in here that are in the metals market. And you can see that the overall business is generally flat over the course of the last 4 or 5 years with a slight growth trend. The key part that I want you to see on this is look at the numbers here. We're talking about 600 robots every quarter or so, which equates to about 2,500 robots a year. 25,000 CNCs that are sold, 2,500 robots that are sold in this industry. So that's when we talk about how automated is the industry. We always kind of are at that 10% range of that we've automated. Maybe 10% of the machines that get sold have a robot on them in some way, shape, or form. What this tells us is that there's still a lot of growth left to happen in the industry, where the true numbers of robots that are getting sold in the industry are on the order of 2,500 or so robots a year in this market, but the number of machines that are sold are more on the 25,000 range. So there's still not as many automated machines that you think about in the marketplace. And actually, when you think about Mazak's floor out here, it's pretty well represented as probably about 10%, maybe even a little less than the machines. There's a couple robots outside and a whole bunch of machines that are operating as well. So this gives you just a little bit of a picture about the market, how we look at the market. A couple key takeaways is number one, the robotics market continues to grow, and it's been growing since the recession. The automotive market right now is a little bit down, so some of the welding robots are down right now, but outside of the direct automotive space, the robotics market's been growing at double-digit growth really since the recession. And we don't see that much of a slowdown in that market space. Whereas on the machine tool business, this has a lot to do with automotive as well, but we have seen a pretty significant dip over the last year. So even as we're selling less machines, we're still selling more robots. And then the other key takeaway here is that there's still a lot of growth to be done. Only about 10% of the machines that get sold even have a robot considered on it. Okay? So if you're sitting in this room, you probably are at least thinking about automating, or maybe you're thinking about trying to sell automation if you work for Mazak or one of the distributors, or if you're an end user in the room, you're at least thinking about automation. So let's talk about some of the key points of why you might want to automate. And these are some thought starters that if you have other thoughts at the end that you want to come talk about, or you want to talk to anyone here about, we can talk about those at the end. The first and the most important, or probably the most recent and the most popular right now, is about labor and the shortage of labor. As I mentioned, I've been doing this for 20 years, and this hasn't been the number one reason throughout that entire period. Only more recently, really since the recession and since the amount of skilled workers in our market has seen this dramatic reduction, that labor shortage has been the top reason why people are automating. We hear it time and time again that people need to cut parts, they need to make products, but they can't find enough skilled people to be able to be within their shops to do it. And so this is one of the most prevalent reasons why people are looking to automate right now is they need to make more parts, but they can't find the right people. Another reason, and this was a reason that was from a while ago that is still a strong reason, is that the cost that you have per part is too expensive because your labor rates are too high. There's too much labor content for the amount of parts that get produced compared to the amount of labor that's there, results in an uncompetitive price for you as a machine shop, where it's hard to compete in the overall market space. This is where we saw a lot of parts getting offshored. getting lost to foreign countries with low-cost labor because the labor rates were overall uncompetitive. And when I get into some of the benefits I want to talk about, when we start to automate, it's not only, or it's a little bit about changing the labor rates or having less labor, but some of it is to do with it, when you start to automate, you can actually produce more parts with the same machine. That a person on a machine produces X number of parts per day, but a robot on a machine can produce a lot more parts than you can do when you manually tend it. So this is another reason where sometimes your labor rates actually makes you uncompetitive. This is an interesting one where, say you're a one-shift operations shop where you run your normal first shift, and you're on that cusp of thinking about a second shift. Do I start a second shift? Do I bring on extra people to start to run a second shift? One of the benefits of automation is that you can take a few of your machines that are automated, like you see some of the robot cells that are outside, you can load those parts up with enough inventory that's in them. So say there's 4 or 5 hours of part machining that you can put on your robot cell. You can load that part up before everyone goes home, turn off the lights, go home, and let the robot cut parts for the next 4 hours and truly run a lights out operation where you can run your normal first shift during the day and turn off the lights and run, say, a half a shift or even a full second shift on a couple of the machines that you've automated once everybody goes home. So if that's a desire, if you're kind of on that cusp of, do I want to start a second shift or a third shift, you can start looking at lights out machining with automation, where all the machines that you have automated, you can truly run those with no people around. This gets into some of the safety aspects. What about hard to handle and heavy parts? Especially on some of the machines that we have outside, especially as you get into the aerospace industry and some of the heavy agriculture industries. The parts are big, the machines are big, the parts are heavy. They need cranes. They take a lot of time to load and unload, where, although the machining time is really long, the loading time can be really long as well, because you have to pull the crane over. You could potentially damage the part because you're trying to manually move the part around. Robots don't have issues with weight, and I'll show you some pictures later about that. So heavy and hard to handle parts is another way. I'll tell you in a little bit about, you might say that, oh, my machining time's an hour long, why would I ever put a robot in front of my machine when my machining time's an hour long? It wouldn't make sense, but there are still a lot of benefits by automating machines that have hard to handle and heavy parts. Dangerous and strenuous operations. This gets into some of the parts. Maybe you're machining a part that ends up with a ton of sharp edges, where the finished part can be very sharp and dangerous. Or you have a really fast cycle time, and your operators really need to get in and out of that machine really, really quickly, and it's a terrible job. You can't find people that are willing to sit there and go on a 30-second cycle time and load and unload a machine that fast. So whether it's super strenuous or dangerous is another reason. As a job shop, this is one where your customers are asking for it. So if anyone's in here that runs a true job shop, you're competing with all the other job shops in the area. And if the guy down the street has a bunch of robots and shows that they're utilizing the latest technology, sometimes your customers might be asking you, hey, when are you going to start automating and getting into that next generation Industry 4.0 and starting to use automation? And then finally, overall, what we're all trying to do is be more competitive. So you're trying to take cost out of your part. You're trying to figure out ways to make your parts cheaper so you can be more competitive and make more money. So these are a lot of the ways of why you want to automate. Think about that. If you have other reasons that you want to talk about at the end, we can go through that as well. So what are the benefits? This is just going to get through a step-by-step. Some of these might be pretty repetitive, or some of them might be common sense, but just to put them up on the screen. The first one is consistency. When we would talk to end customers about the benefits of automation, we always start to talk about cycle time. So what's your machining cycle time? What's your door open to door close time? And we try to get how many parts per day do you run? So you have this machine, you run this part, how many parts per day do you have? And when you go out and specifically watch an operator tend the machine, you can calculate that. The cutting time is this. It takes the operator this much time to load and unload the part, and so I should be able to make X number of parts per day. But when you actually count the number of parts on a first shift or a second shift or a third shift, the parts are different a lot of the times, where third shift might be less than second shift, or first shift might be worse than second shift, something like that. As a manager, when you're going out to watch one of your employees tend a machine, you know that that employee is always going to be giving you their best effort when the manager's standing behind them watching them tend the machine. What you don't see are the smoke breaks and the extended lunch breaks and the bathroom breaks and the other things like that, where throughout the course of a day, when you're looking at your production, you have to look at not just what the cut-to-cut time is, what the door open to door close time is. You have to look at your actual production and see how many parts you made every day. And I can tell you that when you automate, you can truly look at a door open to door close time, you add how long it takes for the robot to load and unload the machine, and you can multiply that by 8 hours, and you can tell exactly how many parts you're going to get out during that day. First shift is going to be the same as second shift. It's going to be the same as third shift. And not only that, as I mentioned before, you're going to get much more machine uptime, spindle utilization, because the robot's going to work through lunch. It's going to work through the bathroom breaks. It can potentially work into a second shift or a third shift if you want to. So consistency is one of the best benefits about automation, where you know that you're going to get that many parts out of your machine every single day, and you're going to absolutely maximize your spindle utilization. Okay? Quality. This is one where many of you, depending on the industry, might have to put quality checks in. Maybe you check every 10 parts, maybe you check every 100 parts, maybe you've invested in some inline gauging and things like that, or the machine's doing it. But the robot can very, very easily perform gauging as part of its process. I see a lot of the Renishaw gauges outside, some of the other gauge companies that are there. The robot can very easily take the part out of the machine, put it into another gauge. They can bring it to a third party. They can use a vision system to gauge it. And using automation, you can very easily achieve 100% part inspection. The other thing about a robot is that there's never any misloading. A robot is accurate to within tenths of millimeters. It's not as accurate as a machine tool, but it can certainly load and unload parts without ever misloading and damaging parts. So having quality parts coming out of the machine is something that the robot can certainly help with. Efficiency. Efficiency is an area where if you're running multiple operations, op 10 through op 20 or op 30, in a manual operation, you might have to physically create work in process. So the operator that's on op 10 is machining a bunch of parts and creating a bunch of work in process, and then they transfer all that to op 20, and you have big carts and trays of parts between all the different machine types. With automation, because now the robots can be have a lot bigger reach than a person can handle. As you can see in this picture, you can start to handle multiple machines and multiple operations with one robot. This gets into a little bit more if you have a long-running part or a dedicated part that you have on your floor. You can run multiple operations with one robot, with multiple machines, which ends up with a bunch of space savings and cycle time savings when you do that. So efficiency is another big benefit. Safety, as I mentioned before, you can see down at the bottom some really heavy castings that the robot's handling. The big picture in the bottom right is our largest robot. It's the largest robot in the world that can pick up 5,000 pounds. So when we first started getting into automation, that level of payload was unimaginable. And now really any part that you have up into that 5,000 pound range, the robot can pick up, and it works just like a robot that's picking up 5 pounds or 10 pounds. The programming is the same, the mechanics are the same, where you can get into really, really heavy part operation with automation. And you can imagine the cost savings by using a robot as opposed to some level of dedicated operation there on the heavy part side. Okay, so how do I get started? Ready? Because I told you all the reasons why you should automate, and I told you all the benefits of automation. So everybody's ready to automate now. So it's really easy. Talk to Mazak, talk to your distributor, potentially find a robot systems integrator, find the right application, and get started. And that's normally the end of my talk. It's really easy, right? You talk about the benefits, you show people how to do it, and everybody should automate. And I've been doing that part for 20 years, and we're still only 10% of the market, and we still haven't been able to automate more than that. That percentage has pretty much stayed the same throughout time. And so it should be that easy. We should be talking about automation. Those benefits are very real benefits. The applications are real applications. But now is where everyone says, yeah, that sounds great. I love hearing all that stuff, but I still want to run my machine manually sometimes. But my people, they don't know about robots. But my shop's too small. I can't afford it. It's too complicated. I have too many parts. I'm not automotive. I don't run 1,000 parts every day. I run 2 or 3 parts and then I switch. And so I've been given that same part of that presentation for a very long time. And then I stop and everyone says, yeah, that's great. And then they go home and they start to say these things. And so I thought when I was going to give it this time is let's talk about some of these things now, because you might be sitting there thinking a lot of those same things of, yeah, that's great, listening to Mike talk, yeah, that all sounds great, but it's not going to work for me. So let's kind of hit some of these points about some of the buts, some of the why, what's so hard about it, why can't I actually do it? And then at the end, let's actually talk about them, and you can bring up some of the things that were really on your mind. You can do it. Trust me, you can do it. I have seen thousands of people automate over the years. I have seen people that you would expect to be successful. I've seen people that you wouldn't even think to be successful be very successful. It is a very easy thing to do. I just want to let everyone know that. The first thing is it all too complicated? I don't know how to connect a robot to a machine and all this, and I'm here to tell you that connecting a robot to a machine is not that complicated. You see a logo down at the bottom here for MT Connect. FANUC and Mazak both support the MT Connect initiative very, very strongly. It is creating a standard protocol on the machine and on the robot. So these connections that are made, having the robot talk to the machine, it really doesn't need to know that much stuff. And the robot needs to tell the machine to start. The machine has to tell the robot when it's done and that the door's open. And then the robot tells the machine to close the door when it's done. There's really only 4 or 5 things that the robot needs to tell the machine at its core level to actually get it to start and stop. And those things have been standardized for many, many years. So if you think that it's hard to connect the 2 things together, a robot and a machine, it's not. It really is not. There are many, many different ways to do that. The other thing that you see, this picture here is a screen from one of our pendants. A lot of people then think that programming a robot's too hard, and I don't know how to do that. I always challenge people that if you have someone that knows how to program a CNC machine, if you have a machinist that knows about how to program a CNC, a robot is so similar to a CNC. You know, FANUC makes CNC controls and robots, and they're both born from the same thing in the beginning. They're both really programmed in the same way. So programming a robot and programming a CNC are very, very similar. I understand that the screens might be a little different, but we're coming up with ways that now, instead of it being more complicated to look at, there are step-by-step screens for new people that don't know too much about robots, where you might just say, you know, I want to load a part, and it'll take you step-by-step through a template program. The system that's over here on the left that you see out on the floor from RoboJob doesn't even use our Teach pendant. They created their own screen where you don't even have to know how to program a robot. You just walk up to the screen and say, this is the size of my part that I want to put into that machine, and it takes you through everything step by step of, all you have to do is say that my part is this size, and it takes you through the whole thing. You don't even actually program the robot anymore. So using MT Connect from an interface perspective, finding easy interface packages, it really is easy. So if you think it's too complicated, it's not. It's easy. The next one is, a lot of people say, well, I'm a small shop and I want to run my machine manually sometimes. And if I automate, then I'm going to need this big expensive machine. There's going to be a big cage around it with a robot, and I'm going to have to dedicate it to automation. And I can't do that because I can't do the automation all the time. I want to find a way that I can sometimes manually tend it or sometimes run it in automation. And there's a lot of examples out on the floor there. All the automation examples on the floor out there show that the front of the machine is open. So if you ever wanted to run it in manual mode, you certainly could. But I wanted to show some other things as well. So the picture on the far right is a robot that's actually on an AGV. So if you have a lot of machines, maybe with long cycle times, it's possible to put a robot on an AGV, and the robot can literally drive from machine to machine to machine and tend each machine step by step. So the robots don't even need to be mounted to the ground anymore. They can literally drive around and tend machines just like a person walking around the plant could be. The other big advancement is with collaborative robots. And that's the green one in the middle. And that robot doesn't need any fencing at all. It works with people. It knows that if it touches a person, it'll stop right away. So with a cell like this, you could also put that cell on wheels and wheel it in and out of the way. But when it's in front of the machine, it doesn't need any guarding at all. And then the cells that you see outside, that's called a fenceless cell, where it has special sensors in it that looks at your legs as you walk close to it, and it knows as you get closer to the robot, it starts to slow down, and then if you get too close, it stops. So automation today, so if you're in your mind thinking, I have too much part variation, I can't dedicate a machine to be automated, I can't do that, I need to run manual sometimes, or I want the ability to run manual sometimes. Most automation these days leaves the front of the machine open, or at least lets you move the robot out of the way if you ever want to, so that it's not a big caged-in robot that's dedicated for automation. The next is, well, I have too many parts. I never know what's going to come next. Sometimes I have little parts, sometimes I have big parts, round parts, square parts. I have a milling application where I never know what's going to come next. And there are so many different, very innovative, flexible part in-feed types. They can handle pretty much any part combination that you might have. So one of the cool things that you'll see out on the floor, again, the picture on the right is another system from RoboJob. That's a very flexible system for both a mill and a lathe, where it's a big grid with pegs in it. So like I said, on the mill, you just say, I have a part that's this big by this big, and it'll say, okay, you need to put pegs on this plate in these locations, and they'll hold your parts into those locations, and the robot's pre-programmed to know all the different spots. So that's a very flexible one. This one right here is very flexible in terms of this array of parts could be one day, and then the next day, you can say their parts are twice as big. You just move these pegs into different spots and hold bigger parts in here, and it can be totally different for this side. This one is more about conveyance. So say you have parts that you want to feed in from the outside and bring in on a conveyor. You can do that. This one uses big pegs, more for a lathe, where you just stick round parts through these big pegs like a big turntable comes in and puts them in. So all these different variations that you have for part types that you can put all different kinds of parts in. So your thought process of saying, well, the only people that automate are automotive companies because they make a million of the same parts and they can dedicate their machines and their things to this is not true anymore. All of these ways are used very, very commonly. This is not rocket science where I'm showing you pictures of things that have never been, or like have only been done once or twice. These have been done thousands of times all around the world. And then finally, even if you get to a part where your parts are big enough or where they can't fit on a conveyor or on a tray, using vision, using a camera to find the part and tell the robot where the part is might sound complicated, but it's also not that complicated. And people are using this all the time as well, where all you would have up here is a camera, and it's just looking down here. This is very simple to be able to do this, find these parts, tell the robot where it is, even in a little bit more complicated standpoint where the parts are sitting in this bin. There's still a camera up here that's telling the robot where to find him. Same thing on the other side. In this case, I think the camera is actually mounted on the tool itself to be able to find it. So programming a robot to utilize a camera to actually find things gives you the ultimate flexibility. You will need to train some of your people how the robot can see new parts in the future. So once you're done running these parts and you get a contract for another part that's generally, you have a machine this size, so you know you're going to run parts that are generally this size. Even if it has a totally different shape, you program the robot to look for a different kind of part and it can see it. So even in this case, the robot can be trained to go find other kind of parts. And again, it's not that hard. It's been done thousands of times, tens of thousands of times over the years. Okay, so this gets into even when you're still saying, I'm not sure if I can do it, you can still do it. And I know that this is a little over the top, but I wanted to show you a little bit about FANUC. And if you really think you can't do it, I want to show you what FANUC does. This is a little bit inside info video. This is inside FANUC's servo motor factory. FANUC is very vertically integrated, the company I work for, and we make a lot of our things in-house. We make all of our own servo motors, we make all of our own CNC controls, all in-house. And because we also make a lot of robots, you can imagine that we're very, very well automated. And so here's just a little clip of how automated our factory. This could be your factory. I mean, FANUC uses so much of its own technology here. This is using robots to insert things, using robots to screw drive things together, using cameras to find things in all the bins in the back. The reason why I feel so confident to tell you that technology is so robust is because we've been using it in our own factories for years and years and years. So thinking that we know how to do all these things, we've done them in our factories. The products are robust, and so I think you can use them as well. So that's just a little bit of inside info on that. So we're sitting here talking now. So I talked a lot about hopefully now convincing you a little bit more on why you should automate. And then you're sitting here talking about my people. And it's going to fall into two categories. Number one, the people I currently have. So if now Mike just talked about all these things and now I'm thinking, okay, I'm going to automate. I have my existing people. And I don't want to lay off people, or I have skilled people that are skilled at machining and now I want to know what to do with those people. Or you're sitting into where you kind of have a section of your factory that's it's making parts, it's doing a good job, but you need to make more parts and you can't find new people, and so you have a hard time making more parts or buying more machines because you can't find new people. So we have your existing people, and then you're going to need to go find new people, because all the things I'm talking about requires a little bit different skill set than maybe what the people on your current factory floor has. So let's talk about people for a minute. First and foremost is for those people that are out there saying that robots are taking everyone's jobs and that the manufacturing business the jobs are getting killed by robots. It just isn't true. None of the data points to that robots are taking away significant jobs. Robots are helping to optimize manufacturing, which is helping to put the labor in the proper spots. As automation helps factories become more efficient, factories produce more things. And the more things that they produce, the more people that they need to do the things that the robots still can't do or aren't very good at. And even in this case, you can see here, this is from the Department of Labor Statistics. This is showing how many hires there are and how many openings there are just in manufacturing. So we can't even find people. This is a kind of steady level of hiring for the people that are out there, but the number of openings that are available continue to rise. And we're seeing this, that people need skilled laborers, and when we can't find them, we're not producing enough of them right now. So one of the things that we have focused on, and I think it's important to think about, is to partner with education. So this is important both for your existing labor force as well as your incoming new labor force. We want to try to find a win-win relationship based off of trust and teamwork with multiple stakeholder areas of expertise. This is the way that we're going to fill the skills gap. My plea to you, or my message to you, is wherever you're located, I know there's folks from all over the country in here, including Mexico, maybe some Canadians that actually made it if their flight wasn't canceled. But partnering with education in your area is critical for two reasons. Number one, it gives you a channel to take your existing labor force and get it upskilled to be able to utilize new technologies like robots and automation. Not only robots and automation, there's a lot of other technologies that could get introduced into your plant as well. But finding local educators to be able to channel your existing workforce through is critical to be able to train them on some of these new technologies that we're talking about. If we don't get your existing workforce to embrace this change, and then maybe take somebody that used to tend one machine all day long, so one of your best machinists might be just working on one machine. We can take that knowledge, that machining technology knowledge, translate it to 10 machines. And now that operator is able to manage 10 machines because all those machines are automated. So you keep that knowledge of the machining skills that are so critical. You add the knowledge to that person about learning about controls and technology and automation. And now that person can tend 10 machines. They can control the robots. They can teach their peers about the robots. And then maybe a maintenance person that you had that was responsible for maintaining the machines, you can train them on how to maintain the automation and the conveyors and the controls and all those other things. And now that person's skill set is much more broad than it was before. And there are schools out there that are just dying to find industry partners to come in and say, I need help. I need help finding people. I need help. I want to funnel some people through your training programs. And so this is a big part about what we have a focus on, and I think you can play a big part in that as well. The way we do it is we're putting actual robots into these schools. Think about 3 levels of education. You have the high school level, kind of a 2-year tech associate's degree level, and then up into the university level. These robots that you see here that we made specially for schools, number 1 go into a 2-year tech program, number 2 go into high schools, and then the smallest portion get into the university level. So the people that we're targeting, the schools that we're targeting, are in that 2-year associate's degree level and into the high school level. Where now the difference, what we're trying to say is the difference is the kids are touching real manufacturing automation. They're not, the stuff like Lego Robotics and First Robotics are all wonderful programs, but they teach a lot more about project management skills and working together as a team and doing things like that, where these kinds of hard skills are literally teaching people actually how to use robots and automation and technology. And so then my next plea to you is then you can see every dot on here is a spot where we have put technology, robots or automation, into a school in North and South America. We're up to over 1,000 schools. There are over 1,100 instructors that are certified to teach about robots and automation. And every year there's about 80,000 students that get introduced to the simulation technology. So kind of talking about and wrapping up this portion is, if you're concerned about people, so you felt a little bit better about, okay, I'm going to think about automating, but now how do I get my existing workforce trained and how do I find new people? Just find one of those dots and we can help you with that. It's on our website. You can talk to FANUC, you can talk to Mazak, you can talk to us about it, and we can put you in contact with a school that already has a strong focus in industrial skills to try to upskill your existing workforce, and then also create a channel for new workers to come into your factory. Okay, so that's about the people portion if you're concerned about that. So what's next? This is, you've got, just talking a little bit longer here, let's see. Okay, in terms of what's next, what are some of the next things? The first is more collaboration between people and automation. I was trying to find a good clip for this. This is kind of the best one I could find to kind of show you what might be possible. So I showed you before some pictures of like the cells that you have out here where there's a robot that's tending the machine and there's no fence around it at all. It's just a robot working out in the open space, and as you get close to it, it stops. Sometimes the people in the robots need to get much closer together than that. And this is a good example of that, and this is kind of what people are opening up their minds to right now, where this is a robot where it literally is working right next to a person. I apologize, this isn't a Mazak machine, it's the best video I can find. I did well on a lot of the other things, but so this robot is taken apart off of a tombstone, but the person is performing tasks. They're the ones unbolting the part. And this is an area where people and robots are able to work literally right next to another while the robot's running in this application. So in this case, because you might say, well, I run these big tombstone machines, and there's no way the robot can unbolt the part, and I don't want to go invest in big automated fixtures and things like that. You can still have the robot handle the heavy stuff, work right next to the person, and then the person can do some of the manual things. Now this process is now significantly safer than it was before because the robot's handling the heavy stuff. The person is still doing the things that are a little bit more manual, like the unscrewing part. But this is one of the big areas about what's next. And more people are finding ways where robots and people are working really hand in hand. And a lot of it has to do with handling heavy parts and letting people do the things that people are good at on the part while the robot's handling the heavier dangerous things. The next thing that you certainly see a lot about out on the floor today, and that everyone's talking about, is the industrial Internet of Things, IIoT, or Industry 4.0, but really talking about data and connectivity. And this is something where, depending on the size of your shop and how much things that you want to pull out of your machines, utilizing data is one of the key areas. And I know Mazak, this is also through MT Connect, as well as some other ways that we are pulling data out of the machines and the robots and trying to find good ways to use it. One of the best ways that Mazak uses and FANUC uses is about reliability and uptime. And so this is just a little bit of the way we use it. So the idea is we have a plant with a bunch of stuff in it. This could be Mazaks and FANUCs and a lot of other equipment that's here, and it's pushing data to a device. This can be using the MT Connect protocol. This can be using different protocols, but the data is coming here, and it's getting collected. And we are using a cloud storage space where this data is coming up into a cloud, and we're running analytics on that data. So we're taking that data and we're trying to look at trends within that data to say either the robot's running differently or worse, or someone made a change, or something happened to that data from a baseline of what it was before. We also, my slides are in a little bit wrong word, but then the thought process is that once we see something different, that the system, the data system, alerts both the customer, you, as well as our service team that say something happened with the data. And all this is happening automatically. And then the thought process being that automatically parts get shipped and delivered and then cycled back into the plant. This is the part I thought was going to come up before. One of the key areas we work with Cisco, I know Mazak works with Cisco quite a bit too, is working with someone to protect that data, especially since we're pushing it up into a cloud, to make sure that it's all secure and protected, which we do with Cisco hardware and Cisco software. This is how a lot of people use data today on their factory floor to enhance your uptime. So that the machines, the machine tools, the robots, the automation are pushing data up into a system where that system is analyzing the data, figuring out things about the data, and then cycling that back through to the plant to say, before something really bad happens, before your machine breaks, before your robot breaks, if someone changed something in the middle of the night, we are going to alert you to that before a major problem happens and it causes downtime in your factory. And hence the name, our software is called ZDT, Zero Downtime, is the software that we promote for that. And so that's how a lot of people are using data. This part of the business is getting more and more prevalent. It's also growing very, very rapidly. There's a lot of companies out there that are accumulating lots of people's data and trying to do things with it as well. But this is another big trend that's in the industry today. And then this is the last one I have, and this is about AI and deep learning. This is probably one of the hardest things you can do in the machine shop. So if this looks like something that you might have on your floor, the easy way to handle this is to have somebody take these parts out one by one and fill up a tray like you see out on the RoboJob cells outside, and have the robot pick them up one by one because they're fixed in the location. Having all the parts jumbled up in a bin like this requires some technology to get them out one by one. And it requires someone that can program the robot to do this. So this uses 3D vision to be able to see it, and then you tell the robot, you kind of say, you have this kind of part, and this is how you pick it up out of the bin. What would be nice is if this robot could think like a person. So if I gave this bin to anybody in this room and said, give me one of the parts out of that bin, everybody would be able to take a part out of that bin and give it to me, no matter what the part looked like, no matter what. That's something that we're really good at, is we can take that part. A robot is not good at that. It is not good at trying to find that. You have to have the right sensor to see it. You have to have the right program to program exactly that it's this shape and this is where I pick it up, and that requires a lot of effort. What if the robot could figure it out on its own? And that's one of the things that we're working on with AI, where in this system, what I'm about to show you is, we've still given the robot a sense of sight, so we're gonna take a picture of what's in here, and the robot knows the topography of what this looks like, but that's it. That's all the robot knows. And the robot's gonna go through a deep learning algorithm and use trial and error to just try different things and try and pick up parts. And sometimes it's gonna succeed and sometimes it's gonna fail. And using this AI routine, you're gonna see that eventually the robot's gonna figure out exactly how to pick up this bin. The downside is it took 8 hours to teach the robot on how to do that. But the upside is that this software works on what's called a neural network, where if you had two robots doing the exact same thing, those robots were going to share their successes and failures together, and then it would only take 4 hours. Or if you had 4 robots, it only takes 2 hours. If you had 8 robots, it only takes an hour, because all the robots are sharing all their knowledge together. So here you can just see, I'll play the video now. So you can see, oh, that, it knew to go try something, it just didn't know where to do it. No, that wasn't good either. So it starts to categorize, oh, I got one. And then you can start to see, as over time, like I said, this can take 8 hours, but I hope you guys are good for 8 hours, right? You want to watch this. Using this deep learning network, it's going to go through successes and failures, and then the network is going to start to say, if I pick up the part here, or here, or here, or here, these are the good spots. So eventually it's going to say, put them up on the ends, or pick them up in the middle. And then by the end, it knows what it's doing. And not only that, it remembers how to do it, so if it ever sees a bin that looks like that in the future, it knows how to do it. And so this is really where a lot of the software is going to be headed, where if we can start to just put random stuff in front of the robots and it just figures it out over time, is another area. This is still a little bit in the future. Clearly this works, but we're still tweaking all this stuff. This isn't for sale right now, but this gives you a little bit of view about what the future might be in terms of using AI and how we're going to do this. I am also here to tell you that this doesn't mean the robots are going to take over the world. This isn't Terminator. We didn't teach the robot how to do anything crazy. It's just picking parts out of a bin. But that's deep learning and things like that. So hopefully that gave you, I accomplished what I wanted to do. I wanted to talk to you about really what are some of the simple benefits, what are some of the pros and cons, really try to convince you you can actually do it, and then show you some of the future stuff. So with that, I'm going to spend some time